Okay, so back with our second set of answers here. So number 8 says they've got the second derivative. So I'm just going to break this up into where it's positive and negative. So basically my graph should be concave up over here, concave down in this section, concave up over here. The only one that satisfies that is this one. So if you take a look here, the concavity changes. They're the same places where positive, negative change there. So we'll go with D. This looks like a limit, but it is a special limit. You'll notice this is a limit definition of a derivative. This is a thing you got to recognize. Doesn't take a sleuth. It's the only one with an h in it. It's the only one where you have a function plus h minus the function. So this entire thing is just equal to f prime of x. So it's just a fancy way of saying f prime of x. So basically this whole thing is just the derivative of him right there, which means this whole thing is just the derivative of him right there, which is 1 over x. If you plug in a 2e, you get 1 over 2e. This one says, here's the derivative, find the third derivative. So basically we just need to take the derivative twice. So we get 4x cubed minus 6x squared plus 3. And then the third derivative is 12x squared minus 12x. And we're evaluating this at 2. So if I plug a 2 in, I get 4, so 48 minus 24, which gives me that answer of 24. 11, I drew a picture of it. It doesn't really matter where this point is. We are trying to find the area under this curve, so we're trying to find that area plus that area. So I have to split this up into pieces. So I've got the integral from negative 1 to 1 of x squared, or sorry, negative 1 to 0 of x squared. And then I got plus the integral from 0 to 1 of x. So I'm going to do these two problems separate. So I got 1/3 x cubed evaluated from negative 1 to 0. 0 makes it 0, so I'll go 0 minus. If I plug a negative 1 in, negative 1 cubed is negative 1. So I'll get negative 1/3. So I get 1/3 for this first area right here. Okay, the second one, I get 1/2 x squared evaluated from 0 to 1. I'm only going to plug a 1 in, so I get 1/2. So we're taking 1/3 plus 1/2. So 2/6 plus 3/6 gives me an answer of 5/6. All right, so I've got this function 3x minus tangent y equals 4. And they want to know the derivative in terms of y, so we're going to solve it for y. So I'm going to take the derivative. This is an implicit differentiation, so I'm going to tag every time I handle a y directly. So the derivative of 3x is 3. The derivative of tangent can either be secant squared or 1 over cosine squared. I don't see any secants in here, so I'm going to go with 1 over cosine squared. And then when that's handling the tangent, when I handle the y, I get a dy dx or a y prime. Equals the derivative of 4 is 0. Okay, so if I'm going to solve for y, or if I'm going to solve for dy dx. So I would add this whole thing over there. Okay, so I get 3 equals 1 over cosine squared y dy dx. And then if I want to solve for dy dx, I'm going to multiply both sides by cosine squared. So I get an answer of B. Give me 1 sec here, I'm just verifying that. Okay, looks good. 13 says the position of a particle is moving along the x-axis with this function right here. It says at what time t in the interval is the instantaneous velocity, that is derivative, is equal to the average velocity, that is algebra 1 slope. So I'm going to find that algebra velocity first. We're on 1 to 16, so I need a 0.1 something and I need a 0.16 something. So if I plug a 1 into here, I get square root of 1 is 1, minus 2 is negative 1. If I plug a 16 into here, I get 4 minus 2 is 2. So I got 2 minus negative 1 on top over 16 minus 1, which would give me 3/15. So I'm interested in when the derivative of this is equal to 3/15. So I'm going to take the derivative. So I'm going to think of p of t as t to the 1/2 minus 2. So I take the derivative. And I get 1/2 t to the negative 1/2. So I'm going to think of that as 1 over 2 root t, which is how I've told you to think about it. So probably should have taken my own advice. Equals 3/15. So we're trying to solve for t here. So I'm going to multiply both sides by this. So I'm going to get 1 equals 6 root t over 15. Okay, so then if I multiply both sides by 15, divide both sides by 6. If I simplify this, I'm going to move over here. So 15 over 6 equals 5 over 2 equals root t. If I want to get rid of the root, I'm going to square this, so I get 25/4. Okay. Here, we're taking the derivative of this, and I want to know what it's equal to at x equals 3. So first, let's just handle the derivative. So we're going to handle a sine first. So the derivative of a sine of something is a cosine of that same thing. So handle the sine. Next, I'm going to handle the f function. So the derivative of f of x squared is f prime of x squared. And then I'm going to handle the x squared itself, so I get a 2x. So if I plug a 3 into here, I'm going to get cosine of f of 9. I'm going to get f prime of 9, and I'm going to get the number 6. So I go look over here, and it's not in the same order, but this matches answer D. Okay.